Well, thank you so much for the opportunity to present today. I'm Toby. I'm joining from Wharawurrung country, as is my co-presenter Sarah, who is in the next room. We just figured it'd be easiest to present this way. And our third co-presenter, Elise, is joining from Yagara and Turrbal country. I'd like to start by acknowledging these traditional custodians and many others on the lands in which we work, the work that these studies have been conducted, and I'd like to pay my respects to the elders past, present and emerging, and note that sovereignty was never ceded, always was, always will be Aboriginal land. Now, when my computer decides to wake up, I wanted to start firstly by apologising to anyone who has seen this intro before, but in case you haven't, I just wanted to make sure that we're all on the same page by asking the question, what is a shorebird? So there's one common example that you might be aware of are the loud abrasive plovers that might have shouted at you in your work's car park this morning. But there are many more species of them here in Australia. These birds tend to forage in coastal habitats such as mudflats, but they can also be associated with any inland bodies of water as well. So there's quite a lot of diversity in this group, and many of them, particularly the ones that we've been looking at, are really long distance migrants, and I do mean long distance. So we are situated here in Australia at the southern end of the East Asian-Australasian Flyway, which is a migratory corridor, one of about 8 in the world, I believe, that links the breeding grounds in the Arctic to, hang on, I'm just going to minimize the pop-up that's just come up there, link the breeding grounds in the Arctic to non-breeding grounds here in Australasia. The birds are quite literally a link between nations along the Flyway, and their conservation and occurrence in these habitats is the subject of multiple bilateral agreements, and they form part of Australia's obligations under the Ramsar Convention and the Convention for Migratory Species, which is a CMS there. They are also the subject of the East Asian-Australasian Flyway Partnership. This 13,000 kilometre migration that some of these species make twice a year is particularly amazing when you consider that the smallest of these species, the redneck stint, weighs about the same as a Tim Tam. And I gave this presentation or this analogy to a conference in the Netherlands where people were not necessarily familiar with the Tim Tam. And so I think I changed their life by introducing them to a Tim Tam slam. And then I disappointed them all by saying I didn't actually bring any Tim Tams with me. So that was an oversight on my part. So anyway, back to birds. In Australia, we have about 37 species of migratory shorebirds, and then prior to 2015, unfortunately, we've been seeing really, really large levels of population declines. So this example here is of the eastern curlew. But what's particularly triggered what we're looking at in this study is the fact that in recent years, we've seen some stabilization in these populations, and we weren't really sure what's contributed to that, whether it was improved survival over the last few years, an increase in the number of juveniles, successful conservation efforts, or a mix of the three, or potentially other inputs. So the team working on this project, there's myself, there's Sarah, who you'll hear from shortly, but there's Professor Marcel Claassen, Dr. Aaron Spence, and Dr. Kay Critchell as part of the Deakin team. And then our wonderful collaborators and co-leads on the project at UQ, we've got Elise, we've got Professor Richard Fuller, and Associate Professor Tatsuya Amano. So the birds that we're working with here are caught primarily by 3 organisations in Australia, the Australasian Wader Study Group, Queensland Wader Study Group, and Victorian Wader Study Group, and this has been occurring since about the mid-1970s. These groups consist of volunteers who capture the birds as seen in this photo. That's through cannon netting. I will leave the drama of cannon netting to be explained a bit later by Sarah. And then all of the records from these birds have now been collated in an online platform called Birdmark. So when we capture birds, we fit them with a Australian bird and bat banding scheme metal band. It's managed by DQ, and then we also put leg flags on a number of these birds. So this ruddy turnstone in the picture here has a leg flag that says XHB, which means that we can actually identify the birds at a distance without catching them. So all of this data, including people, citizen scientists going out observing birds, have been uploaded into Birdmark, which is the main repository for all of this data. Side note, little plug, if you're ever out watching birds and you see birds with the leg flags, go to www.birdmark.net and please upload your sightings, because this is exactly the kind of work that is used from all the data collected there. And to give you an idea of the scale of it, we've got almost, probably at this point, it might be about 600,000 observations over the last 50 odd years from over 80,000 individual birds from 12 different species. So it's quite a remarkable data set. And using this data set is what we've put together as the main deliverable from the Deacon side of this project, which is the survival dashboard. So I'm going to give you a bit of a run through of what this entails. It's not yet live to be publicly available, but it will be before too long, and I can help provide that link to people as well once it's fully online. But everyone who's as another side note, everyone who has ever taught me anything about presenting slides would hate this slide because there's a lot of words on it. Please don't read the words. This is just a screenshot of the landing page. But so we've got this introduction here about the project on the main page of the dashboard. And then when you scroll down on the project, you've actually got a series of species indices. So we've got 12 species in the project. And if when it's live and you click on these photos, it'll take you to each species particular profile page. So I'll give you a bit of a rundown then of the sitemap, so how we've structured the website. So we've got, for each species, there's a species profile. It gives you a little bit of history, natural history about the species, bit of their ecology and conservation status. And then there are 4 main tabs underneath this on each page on the dashboard. The first one of these is looking at the locations at which birds have been caught and the site fidelity, so movement between the sites. There's a second tab on the capture summaries, which gives you an idea of the temporal spread and locations at which birds have been caught. How many of them are new captures, how many of them are recaptures, and you get an idea of just the sheer volume of data that has been collected by these groups. Third, and this is my key part of the project, has been the survival analyses. So we've been looking at using all this data for each species, calculating an average survival per year. And then finally, we've also got a tab on the juvenile proportions data, which is where Sarah comes into this project. For any shorebird buffs in the room, I do apologize for the fact that my baby turnstone in that picture is just a very small adult turnstone. It's not accurate, it was for illustrative purposes only. So on the page where we're looking at sampling locations, we've got some interactive maps on there that allow people to zoom in, see how many birds were caught at each location around the country. Particularly useful for people in these particular regions to see where their birds are and where their birds have gone. And so this also underpins everything else that we did across this dashboard, because we needed to first know whether or not these birds are faithful to specific locations, or if they are considered as an entire population across all of Australia. And what we found was, I'll just walk you through this actually. So on this circle plot here, sorry, I'll continue. So what the circle plot shows on the outer edge there, where the arrow starts, is where the birds were first seen, and then where the arrow goes is where the birds were then seen the next time for any subsequent observations. And so you can see, by and large, most birds in this site here, the red one there, the brown one is in Broome. Birds were primarily sighted at the exact same location that they previously were. Same story goes here for the birds at 80 Mile Beach, and then again the same story goes for the birds seen in Port Phillip Bay. There's a little bit of exchange though, where you can see birds from Broome and 80 Mile Beach have swapped locations, but overall there is exceptionally high site fidelity in these species. And we see this across nearly every single species that we've looked at, site fidelity of over 90-something%. And so that was a really important thing to know, firstly, so we could then treat each location as its own population for site fidelity, for survival analysis, sorry. But it also shows that the location and knowledge of these locations is really important to shorebirds. So the most important habitat to them is where you see them. And so forcing these birds to move may actually incur a cost for them in their survival. And we've actually managed to publish this already. It's really, really cool because it's an opportunity to get all of the data that's been collected by these groups together and highlight just how valuable these habitats are to the shorebirds. So following that, we've got the capture summaries tab, which has information. So this is an example of black-tailed godwits. Again, these plots are interactive. You can click and drag to look at specific time periods as you're after, particular locations as well. In the case of black-tailed godwits, it's probably not the best example because the main location which they are caught is Roebuck Bay and Broome. But it gives you an idea of just how many of them are caught and then how many of them are resighted and recaptured. So it really illustrates the extent to which all of this data the amount of effort has gone into the data that's being used in these analyses. So for the main part of what I'm sharing today are the survival analyses, which is the third key tab there. And on this tab, we've got two main lines you can see. Sorry, I'm hearing someone else there again. And so the models that we've used are Bayesian Cormack-Joly-Sieber models, but we've structured them. I won't get into the details of the models themselves, but the structure we've got is that we've calculated an annual survival in adult birds for each year, and then an average survival in juveniles across the board. And the reason we've done this is we have far less data from individual birds because they're only juveniles or immatures for a year or two before they become adults. And so it's a much smaller amount of data. The error around each year's estimate would be much, much bigger. So we figured we'd just focus on what the average juvenile is. So you can see that if I go back a couple slides, that dark blue line is the average juvenile survival across the entire time, whereas the light green one is adult survival that changes from year to year. So at this point, I thought I would give you a bit of an overview of some of the things we've found in this survival data. And so one of the very first things that stands out amongst a number of species is the fact that around about the 2005 mark, 2004, 2005, 2006, all of a sudden, we start seeing that the estimates for the survival of these birds are much more accurate after that point in time. So you can see it here really well illustrated in the bar-tailed godwit. You can see it really nicely in the great knot, and then you can also see it really nicely in the red knot. And part of the reason for this is that's the point in time where we did introduce leg flags. So leg flags are the gold standard for marking birds because it does allow a much higher effort without actually having to catch the birds. And then it also means that we have a really, really accurate estimate of survival. So when catching birds, chuck your leg flags on them. The second thing we've noticed is that in some of these species, such as the bar-tailed godwit, red knot, and great knot, we have around about the 2006-07 mark, there's a 2 or 3 years where survival is notably reduced by comparison, just a little, but enough to be notable when compared to later years. And that is what we're seeing in, again, these top 3 species here, but not so much in ruddy turnstones, curlew sandpipers, and redneck stints. Part of the reason we think for this is the fact that, it's just frozen, give me a moment. There we go. This coincides with the closure of the Saemangeum seawall in South Korea. So this habitat, this estuary that you can see on the left here, it was a massively important location for a number of these shorebirds, particularly great knots and bar-tailed godwit. And so in 2006 was when that seawall was finally closed, and you can see just the sheer loss of habitat there. So the counts in the area drastically reduced with the closure of that seawall, and it seems that we're able to actually pick that up in the survival of the birds, which again ties back to the site fidelity that we're talking about. If you remove the habitat that the birds use, they're not necessarily very able to switch to a new habitat, and so instead they likely perish. When we're looking across, I hope you're all still with me at this point, when we're looking across all of the survival estimates for all of the species, we've run them through a principal components analysis, and we can see some of the groupings come out here where you've got species such as sanderling and sharp-tailed sandpiper tend to cluster quite close together when taking everything into account. These are species that don't generally show much in the way of far less site fidelity, and they also don't show delayed maturity, wherein they are juveniles or immatures for more than 1 year. They mature very, very quickly, these species, and they move a lot. So it's not surprising to see that they cluster in a similar fashion to one another. There's another big grouping here of the grey-tailed tattler, greater sandplover, pteryx sandpiper, and black-tailed godwit, none of which are quite as high Arctic breeders as the other species that we studied. And then all 1, 2, 3, 4, 5, 6 of the other species kind of spread out everywhere else. And these 6 species are all particularly high Arctic breeders. And then noticeably redneck stint sticking out on its own out to the left there, that's a species that has a different population trajectory to the others, and that it has not shown any demonstrable declines in population numbers. So I'm going to throw a whole lot more graphs at you. I do apologize in advance. Feel free to ask questions afterwards. I'm happy to go back and explain things. But for each of the species, I've run 2 models. We've got the blue line here shows just an average trend across all up to 50 years of data. And then the red line shows a moving kind of a moving average of the data to show how survival has changed in certain windows of time throughout the sampling period. And so for all 6 of these species, we can see that there is a decline in survival over the last 50 years. However, you can see that that's not necessarily as straightforward as that. Redneck stint's a really good example. In the last few years, survival estimates have really picked up by comparison to the previous years. And the same kind of thing can be seen a little bit with the Terek sandpiper. So they might be declining overall, but it's not necessarily the same at all points of time throughout the sampling period. To contrast this, we've got these 3 species, black-tailed godwit, red knot, and ruddy turnstone, which appear to be having overall over the last 50 years an increase in the survival of the birds. However, you can see there with the black-tailed godwit and red knot, the last few years have not been quite so good for them. So that trend might change overall when you look at that red line. Finally, we've got 3 species here where we don't see any major trend in the survival of these birds. It changes from year to year, but the overall over the 50 years, it doesn't seem to have changed all that much. But then when you look at sanderling and curlew sandpipers, for example, that average survival across the board is a little bit lower than the other species. And then the really odd one out here is the sharp-tailed sandpiper, who are bizarre little birds that move around in a way that other shorebirds really, really don't. And if you ever see shorebirds on inland waters, it's sharp-tailed sandpipers because they are quite a different species. But that's where we're at for the survival analyses. We're in the process of disentangling this. It is quite a complicated situation. But so there'll be more to update in this space, but that's where we're at the moment. And before too long, we should have these available online for people to view and have this dashboard annually updated as more data comes in. Now, the last part of this dashboard is the information on juvenile proportions. So I'm going to pass this over to Sarah to explain this section of the dashboard.
Thank you, Toby. So yes, as Toby outlined, survival is one of the reasons we think maybe populations have stabilized. And as Toby showed as well, there are variable responses between species. Another reason that abundances can stabilize or change is because of their breeding success, which we can infer in these shorebirds using juvenile proportions. And so that is looking at the non-breeding ground, seeing how many of the individuals are juvenile and how many of them are adults as a proportion to each other. And that way we can infer what the breeding season was like and how successful it was. So that was the analysis that I took charge of. I used a data set of nearly 270,000 birds from 1981 until 2025. And this was across 11 different species, most of the same ones that Toby looked at. But in this case, we also considered 2 different subspecies for both the bar-tailed godwits and the red knots. And that's specifically because those 2 subspecies have distinct breeding ranges that we think might play a role in what their breeding success could be like. So we wanted to make sure that we separated them. The juvenile proportions, we also linked them to environmental variables like temperature and rainfall. So we did some environmental data extraction and modeled it all in phylogenetically controlled modeling frameworks so that we could account for the relatedness between the species. Next slide, please, Toby. Perfect. So overall, there is a general increase in juvenile proportions through time. And that is probably driven by that there is generally a positive relationship between temperature on the far left and their juvenile proportion. So when temperatures are higher, they tend to have in the breeding ground, that is, when temperatures are higher in the breeding ground, they tend to have higher breeding success. For all of these species, there is an increase in temperature in their breeding range. When we look at rainfall, overall, there's a negative influence. So rainier years tend to lead to lower juvenile proportions, so maybe less good breeding. Whereas NDVI, which is this vegetation index, so it's kind of an indicator of productivity in the environment in the breeding ground. That has quite a mixed influence on juvenile proportions. And the reason for that could be because, well, productivity is driven by a combination of temperature and rainfall and snow and all these other variables, but nonetheless, it leads to quite a complicated sort of relationship there. Next slide, please, Toby. Now, the whole goal of this project was to link these different processes to the abundances and how they have stabilized. So what you're seeing here are a couple of examples where In the red line and those blue bars, that is the juvenile proportion for a specific year, and that red line is the trend in juvenile proportion through time. The gray line is the abundance estimates through time, as from a previous NESP project that Professor Richard Fuller and colleagues worked on. So what you can see here, if we start at the top with the red knots, is that generally their juvenile proportion is actually decreasing. However, if you look at their abundance, there isn't really an obvious tracking between the juvenile proportion and what the abundance is like. If we move down a step to the bar-tailed godwits, they generally have an increase in juvenile proportions through time, but they have that decrease in abundance. So even if there is an increase in juvenile proportions, in this case, it doesn't seem to necessarily translate into an increase or even a stabilization in the population's abundance. And then as a final example, the ruddy turnstones show generally a decrease in juvenile proportions, and they also show a decrease in abundances. So here there is maybe this link between juvenile proportions and abundances, but as the previous examples showed, we can't really say that the decrease in abundance is because of this decrease in juvenile proportions. Next animation, please, Toby. I thought as well I would show you guys, I guess, the ultimate product here. And so these are the slides that you, or the plots that you saw from Toby. So this is the survival for each of them. And the point that I'm wanting to make with this one, and then the third one, is that all of these different facets of juvenile proportions, of the survival that Toby has been modeling, and of the abundances that Richard Fuller and colleagues have been modeling, they create a very complicated picture. And there isn't necessarily a very clear one-to-one, this causes that type of relationship. And so as a team, one of our next step is going to be to try to integrate these different facets and really understand how they play off of each other, how they interact with each other, and what this all really means for the shorebirds. Because as you probably gathered from Toby and my presentations, there are different trends that are happening between the different species, and we're really interested in seeing how this plays out for their population abundance and for their species trajectories. And with that, I'm going to pass off to Elise.
Thank you, Sarah. So in addition to examining the survival rates and juvenile proportions for shorebirds, we are also interested in finding out if conservation efforts could have contributed to the stabilizing trends that we are seeing. So where shorebird conservation efforts here would refer to the protection and management of shorebird populations in order to ensure their long-term survival, where these efforts encompasses a range of different activities as shown on the slide here, such as removing feral predators or restoring degraded habitats to provide high-quality feeding and roosting areas, as well as protecting habitats from human-induced disturbances. And to do so, we conducted a literature search for a global literature search in this case of almost about 15,000 papers from 4 different languages, major languages across the region. As well as to get an insight from practitioners on the ground, I did a survey and interview process to figure out what they have done that may not be necessarily captured in the literature. So from the literature review, we found that evidence for our species were largely from evidence that were outside of our flyway. So coming mostly from Europe, where on the screen this refers to the blue bars that are on the left, where they have conducted extensive and rigorous studies to figure out whether conservation efforts work or do not work. But the risk here is that while these actions may not necessarily be transferable for our flyway context, because over here in our flyway, we are interested in the non-breeding aspects, whereas in Europe, they are mostly focused on the breeding aspect of the life cycle for migratory shorebirds. And this means that endemic species, highlighted in the red arrows here, have very few conservation actions conducted for them, if any at all. And in the case of the Far Eastern curlew that we saw Toby saying that it's declining, we do not have any evidence for any conservation efforts for them so far. And while there aren't as many conservation efforts that have been conducted in our flyway, where so far I've only documented of the subset 15 studies out of the 116, the type of actions conducted within our flyway is pretty similar in proportion to those that have been implemented outside, so the global scale more broadly, where most actions typically address threats from agriculture or implement habitat restoration and creation. So importantly, based on the evidence that we have so far, most of the actions appears to be effective, as seen in the blue blocks up top. However, this pattern may be influenced by a publication bias, as studies reporting neutral or negative outcomes are often less likely to be published and therefore may be underrepresented in the literature database. It's also important to recognize that some of the conservation efforts may not necessarily be beneficial across all species, indicated by the orange bars on the bottom, where there's mixed effectiveness. So local managers should be aware and carefully balance the potential benefits against any negative consequences for non-target species. So putting together the information from the survey data as well as the published literature, we see that there is this appearance of this block in green, relating to education and awareness raising, which is a widely implemented action, at least on the ground, but not represented in the literature, largely because such actions are typically not assessed or evaluated for their effectiveness. And then moving on to the context of threats, how well do the implemented actions address threats faced by migratory shorebirds? First up, we have habitat loss and agriculture, which are leading threats for shorebirds. And based on our results so far that we have, this seems well addressed by the implemented actions that have been addressed by 3 different categories indicated by the red arrow shown there through, threats there. And then moving on from that, the next threat that we have sort of identified is from disturbances from human interference activities such as four-wheel drives and dogs on beaches that can cause stress and interrupt feeding and roosting behaviors. But such actions are not as well represented as threats from the previous 2 threats, where only a very small proportion of actions are there. And next, we have hunting and bycatch that has been documented to have substantial impacts on populations. But this is also similarly not well covered by the implemented actions, with only 2 instances where such actions have been implemented in Myanmar and Bangladesh, where they offered alternative livelihoods to hunters to encourage them to stop hunting. Last but not least, we have climate change, which is an impending threat with sea level rise and more extreme weather that can impact shorebirds. But thus far, we have not seen any actions relating to addressing such change from climate change. So putting it all together, all the actions that we have assembled will be put together to develop the handbook, which is the second deliverable for this NEST project. And here I'll provide a sneak peek into one of the action pages to provide a preview as to what it will look like. So first up, we have the background section, which will provide context as to the action and how it will benefit migratory shorebirds. Next, we'll have the key message section that will synthesize the evidence from the individual studies to provide understanding onto the effectiveness of the action. As well as, last but not least, providing the supporting evidence from the individual studies that make up this handbook. And this will include a concise summary of each of the actions, as well as the species involved and the overall outcomes. So here are some of the key recommendations emerging from Project 4.17, where first up, we'll encourage everyone to go outside, as Toby has mentioned, that a lot of the survival analysis and site vitality results do derive from conservation, citizen science results, where we need input to understand and be able to detect impacts on populations into the future. Next, we have the recommendation to conduct more homegrown studies that test the effectiveness of conservation actions for migratory shorebirds. While we can learn a great deal from studies from elsewhere, it is important to know that these actions are effective in our own local context. Next is that we want to encourage the evaluation of effectiveness of implemented actions, as education and awareness raising initiatives is widely implemented, but right now there is little evidence that this has been evaluated for their effectiveness, and this is likely because it requires long-term monitoring and sustained investment. However, if we want to be confident that the limited conservation resources that we have is being directed to the most effective interventions, this is a critical area for future research. Last but not least, to ensure that conservation evidence is both accessible and up-to-date, so evidence should be regularly synthesized, updated, and made available to those who most need it, such as practitioners and site managers, so that management decisions can be guided by the best available knowledge. So in summary, pulling it all together, what we have presented so far, Toby showed us that migratory shorebirds have extremely high site fidelity, but survival is highly variable depending on species. Then Sarah showed us that juvenile proportions are generally increasing, but does not necessarily link well to abundance trends. Last but not least, conservation efforts are generally effective, but there is a need for more assessments and efforts in our lone local context and flyway. And with that, I thank everyone for listening to us, and we'll take your questions.